All right, today we are pulling back the curtain on one of the internet's most critical, but honestly most invisible technologies, network address translation, or NAT for short. It's the unsung hero that makes our modern internet experience even possible.
Have you ever actually stopped to wonder about this? I mean, think about your house right now. You've got a laptop, a phone, a smart TV, maybe a gaming console. All of them are online, all at the same time, through one Wi-Fi router. How do they all share that one single pipe to the internet? Well, the answer is NAT.
So, to really get why NAT is so important, we have to rewind a bit, back to the internet's early days. It was built on a system called IPv4, which had a fixed, limited number of unique addresses. As the internet just exploded in popularity, we started running out of them fast. It created this huge problem that honestly threatened to stop the internet's growth in its tracks.
Okay, so here's how we're going to break this down. First, we'll dig into that address problem. Then we'll see how NAT came along as this really clever solution. After that, we'll look at the three main types of NAT. We'll follow a single piece of data on its journey to the web and back. And finally, we'll peek inside the router's memory to see how it keeps everything straight. Let's do it. So yeah, the stage is set. We have literally billions of devices trying to get online, but only about 4.3 billion unique IPv4 addresses to hand out. That scarcity was a massive bottleneck. We desperately needed a way to let lots and lots of devices share a single public address.
And this is where our hero, NAT, enters the picture. It was this absolutely ingenious workaround that pretty much solved the address shortage overnight. NAT lets an entire private network, like all the gadgets in your home or office, get on the internet using just one single public address.
So what is it technically? Well, NAT is a technique that translates those private internal IP addresses into a public external one. The best way to think about it is like your router is the receptionist for a big office building. The building has one street address, that's your public IP, but inside you've got hundreds of employees at different desks. Those are your devices. That receptionist manages all the mail, right? They make sure outgoing letters have the main building address and that any incoming mail gets to exactly the right person. That's precisely what NAT does for your data packets. But here's the cool part. NAT does more than just save addresses. Sure, that's its main job, but it also gives us a fantastic, almost accidental security benefit by hiding your internal network from the outside world. Plus, it gives us tons of flexibility to set up our home networks however we want without causing any chaos. Now, NAT isn't a one-size-fits-all kind of deal. It actually comes in a few different flavors depending on what you need it for. So let's take a quick look at the three main types. This table lays it out really well. First, you have Static NAT. That's a simple one-to-one mapping, perfect for something like a public web server that needs a permanent, unchanging address. Then you've got Dynamic NAT, where your internal devices can just grab a public IP from a small pool whenever they need one. But the one that most of us are using every single day is the third type, PAT, or Port Address Translation.
And yeah, PAT is the real magic here. It allows many, many, many private devices to share one single public IP address by cleverly using port numbers to keep track of all the different conversations happening at once. This is the tech that's humming away inside your home router as we speak.
So how does PAT actually pull this off? You know, to really get it, let's follow a single packet of data on its complete round trip, from your computer out to the internet and all the way back. Okay, so the journey begins the second you click a link. Your computer, with its private address like 192.168.1.10, creates a data packet. That packet heads to the router, our receptionist, who stops it at the door. The router then swaps your private address for its single public address, and, this is key, it makes a quick note of this swap in its logbook before sending the packet out onto the internet. Now, when the website sends a response back, it only knows one address, your router's public IP. So the packet arrives there. The router immediately checks its logbook. It sees the note it made earlier and says, aha, this response is for the computer at 192.168.1.10. It then swaps the public address back to your private one and delivers the packet right to your computer. It's a flawless delivery every time. So that logbook we keep talking about is really the secret sauce to this whole operation. Its technical name is the NAT table, and it's how your router can manage hundreds of different conversations at the same time without ever getting confused. And here's a simplified look at that table. You can see the router maps an internal device's private IP plus a unique port number to its own public IP and a corresponding unique external port number. So when your laptop and your phone both visit a website at once, the router gives them different outgoing port numbers, like 15,000 and 15,001. That way, when the responses come back to those specific ports, it knows exactly which device gets which data. It's brilliant. So really, the bottom line is this. NAT is so much more than a simple address swapper. It's the ultimate multitasker. It's the network's traffic director, making sure every piece of data gets to its correct destination, and it's also your network's security guard, shielding all your private devices from being directly exposed to the public internet.
And that brings us to a really interesting final thought. The internet is slowly but surely moving to a new system, IPv6, which has a nearly infinite number of addresses. So that makes NAT's address-saving job, well, kind of obsolete. But what about its role as a security guard? Will that accidental feature actually become its most important job in the future of the internet? It's a fascinating question, and one we'll see answered in the years ahead. Thanks so much for watching.